Assalamualaikum and good afternoon, okay, to all my students, okay. So today we are going to see our first lecture, or to hear our first lecture, okay. We have MTS 3013 structured programming. Just for introduction part, I'm not going to go into the programming part yet, okay. But for today we are going to do just the introduction. We are going to see the terms that we have in the computer, okay, because some of students are not familiar with the term, okay. For example, you might you maybe do not know what is the meaning of program, what is the meaning of programmer. So we are going to see the terms after this, okay. So maybe some of you have used or have done the programming before this, so for this student you have no problem. But some student, okay, who comes from the STPM or STAM, okay, I think you are not familiar with this term. So we are going to see this term before we move to the problem solving in this topic, right? So we have to see the first, okay, and then the first term computer, and then we have the program, and then we have the programmer, right? Okay, now we go to the introduction part first, okay. Okay, so we want to know what is the meaning of computer first, and then what is the meaning of program, and what is the meaning of programmer. So first, computer. I'm sure all of you have used the computer before this, okay. So a computer is an electronic device capable of performing commands given by human. Computer electronic device, okay. It will perform the commands that given by human. Human must give them the commands or the instruction, then they will perform. So that is computer, okay. So what is a program? Program, sequence of instructions and decision, okay, that the computer carry out to achieve a task. Okay, so you have a sequence of instruction or decision. So all these instruction and decision, okay, the computer will carry out to achieve a task. So must be a specific task to achieve. So that is the program. After this, we will learn the program in detail. Okay, we want to learn how to do the program. Yeah, okay. And then the third one is programmer. What is the meaning of programmer? The person who write the program is the programmer. Let's say you do the program. Okay, so you are the programmer. Okay, so you have to differentiate between the program, programmer, and then a computer itself. Okay, so this term is very important to you, right? And then we have the we want to learn the learning programming. Okay, what is the meaning of learning programming here? We learn to solve the problem using computer. Okay, when you learn programming, you learn how to solve the problem, but must use the computer. Before this, okay, you learn how to solve the problem. Okay, you learn in mathematics, you have the problem the problem, then you solve the problem, but you use only pen and pencil. But now when you learn programming, you learning programming, you want to solve the problem, but must use computer. Meaning here, once anyone who learn programming, they must use computer in order to solve the problem. So that is programming. Okay, so this is the introduction part, and then we move to the computer solving using problem solving using computer. So now you have know already what is the meaning of computer, what is the meaning of program, and then what is the meaning of programming. Okay, and then you have know when you learn programming, you must learn how to solve the problem using computer. So now we want to problem solving using computer. Okay, so we are talking about problem solving but using computer because we want to learn programming. Okay, so in order to solve problem using computer, okay, we have to involve programming here. Okay, we have involved programming here. It will involve 6 phases here. Okay, you have 6 phases you have to know. Okay, what is the first one? You have to define the problem. Define the problem meaning you have to understand the problem needs, okay? And then problem analysis, you have to do the analysis, and then design the problem solving, you have to design, okay? You have to do the design for the problem solving. After that, implementation, test and verify, and then documentation. Okay, if you see here, for the number 4 until 6 here, okay, this part, okay, or this space, we are going to use the programming language. So we I will first this space, okay, implementation, test, verify, documentation. We want to focus on the define the problem analysis, and design the problem solving first, okay, not this implementation, test and documentation. Okay, so that is the place that we have in order to solve the problem by using computer. You have 6 space here: define, and then analysis, design, okay, implementation, test and verify, documentation. But we want to focus only for the first 3 here. Okay, first 3 here, because this space, okay, we are not going to use any programming yet. All right, we want to understand the concept first, how to solve the problem solving. Yeah, okay. Okay, now we want to go into detail, okay, about the passes just now. Okay, we have the first passes just now. You have the define the problem, and then you have the analysis, and then you have to design. Okay, so now we are going to see into detail about these passes, um, about this person, define the problem, and then problem analysis, and then design the problem. So now we go to the first one, okay, define the problem first. Okay, when you have the problem, okay, let's say you have the problem now. For example, okay, the problem, I want all the student calculate the area of the circle, for example. So the problem is calculate the area of the circle. So when you have the problem, what you have to do? Okay, first you have to read the problem, and then you have to understand. Okay, let's say the problems calculate the area of the circle. So you have read the problem, calculate the area of the circle, and then you understand what the problem needs. Okay, so that is the first one, define the problem, read and understand the problem. And then the second one, after you understand what the problems need, okay, then you have to do the analysis, problem analysis. Okay, when you do the problem analysis, you have to identify 3 main things. And 3 main things you have to identify. The first one, what is the input from the problem, and then the input meaning the data. Okay, sometimes you have the data there. Okay, and then what is the process that you have in that problem. Okay, either you have to use the formula, or you have to see the problem. Okay, and then what is the output. So we have 3 main things here. You have to identify input, process, and output. Okay, so sometimes we call IPO, input, process, and output. Okay, so after that, okay, okay, here I have the input, process, output. So you have the input, and then you have the process, and then you have the output. What is it? What is the input that you get from the problem? What is the process that you want to do? And then what is the output that you plan to get. Okay, so that is the problem analysis. Then after you do the problem analysis, okay, you do the design. Okay, the design the problem. Okay, normally we use the algorithm in design the problem, in designing the problem. Algorithm might be you can use a flowchart, or you can use a pseudocode. I will go into detail about the algorithm, flowchart, and pseudocode after this. Okay, so you have to define the problem, you have to do the analysis, and then you have to design the problem. Okay, so now let's say here, okay, okay, now we go to the page number 3. Okay, in page number 3 we have to design the problem. So in order to design the problem, normally we use the algorithm. So you have to understand what is the meaning of algorithm first. Okay, so what is the meaning of the algorithm here? Okay, step that should be followed in order to solve the problem. So you have to follow the step by step in order to solve the problem. So step by step that we have to follow in order to solve the problem. So that is the algorithm. For example here, okay, I use the example here, a cookie recipe. Okay, you need to follow each recipe instruction in order, beginning with the first instruction and ending the last. Okay, so you have to follow. You want to, let's say you want to bake a cake, you have to follow the step by step in order to get a nice cake. Okay, so let's say I want to cook the rice. So what are the steps involved that you have to follow in order to get the nice rice? So you have to think for this algorithm for the cooking rice. Okay, so in our normal life, okay, daily normal life, we have a lot of example that we use the algorithm, meaning here, in order to get the output, in order to solve the problem, okay, you have to follow the step by step. Okay, if you miss one step, then you still get the output. Maybe you might get the output, but the output is not nice. For example, you don't get the nice cake, for example. Okay, so that is the algorithm. So you have to bear in your mind, algorithm is step that we have to follow, okay, in order to solve the problem. You can't miss any step. Okay, if you miss one step, then okay, you still get the output, but the output is might be wrong. Okay, might be incorrect, right? Okay, so that is algorithm. So now we want to move to the we have to see the example here. Okay, we have the example here. Okay, example, I use the example of robot here. Okay, a robot named Didi. Okay, Didi can understand only a specific number of instruction or commands. Okay, what Didi can understand, the commands here, Didi can understand walk, turn, and then sit. Okay, walk meaning take one complete step forward. Okay, walk, take one complete step forward. Turn meaning turns 180 degree. Sit meaning sit down. Okay, so if we ask the Didi to walk, meaning Didi will take one complete step forward. Okay, and then turn meaning Didi will turn 180 degree. Sit meaning Didi will sit down. Okay, assume that Didi is facing a chair. Okay, now you just imagine Didi is facing a chair that is 2 steps away from him. Okay, after this we will see the graphic. We have the graphic there. Okay, okay, Didi is facing a chair that is 2 steps away from him. Write the instruction using only commands that Didi understand. What are the commands that Didi will understand? Walk, turn, and sit. Okay, so we have to write the instruction using only commands that Didi understand, that direct Didi to sit in the chair. You want to ask Didi to sit in the chair, but Didi now is 2 steps away from chair. Okay, so this is the, if you see here, okay, this is the chair. Didi is 2 steps away from the chair. Okay, now we want Didi to sit on the chair. So what are the instructions that you have to give to Didi in order to make sure Didi will sit on the chair here? Okay, so we have to use walk because Didi is 2 steps away from the chair. So you have to give the instruction walk. Okay, walk again. Okay, and then turn meaning turn 180 degrees. Then after that, Didi sit down. Okay, so this is the algorithm. Didi have to follow this algorithm. They have to walk. Didi has to walk, and then turn, and then sit down. Okay, so algorithm here, a set of step by step instruction that completes a task. Okay, meaning we have to follow the step in order to complete this task. Okay, what happened? Okay, what will happen to Didi if Didi walk only once here? Walk, turn, and sit. So what will happen to Didi? Didi will sit, but not on the chair. Maybe Didi will fall on the floor here. Okay, because Didi not follow the instruction that he has to follow. Okay, so he has to walk 2 times because he he is 2 steps away from the chair. So that is the meaning of the algorithm here. The step that we have to follow in order to sit, in order to get the output, or in order to accomplish the task. Okay, that is the first example. Okay, now we move to this example here again. Okay, now we use the same example, DD again. We have the DD again here because I want to make student clear what is the meaning of the algorithm first. Okay, for those who have learned the programming, who have learned the computer, I'm very sure you have learned about this algorithm, so you don't have any problem. But for those who are new, so you have to know, you have to clear what is the meaning of algorithm. We have the second example here. I use the DD also. Okay, the example of DD also. Okay, DD is facing a chair that is 50 steps away from him. Okay, so a chair now 50 steps away from him. Just now 2 steps away. Write the algorithm that directs DD to sit in the chair. Okay, now we have to write the algorithm to direct DD sit in the chair. Okay, in the chair again. But okay, what is the algorithm that you have to use, okay, in order to instruct DD to sit on the chair, or in the chair, on the chair, okay, on the chair here, right? So if you see here, okay, we have extra command here, repeat. How many times here? We have to repeat 50 times. Okay, solution here, we have write walk instruction 50 times, use the repeat 50 times. Okay, so repeat 50 times walk, and then turn, and then sit. Why we have to repeat 50 times? Because DD is 50 steps away from the chair. Okay, so DD has to repeat 50 times. Okay, walk until 50 times, and then turn, and then sit. Okay, so this is the repetition. DD has to repeat walking until 50 times, and then turn, and then sit. Then DD will sit on the chair. Okay, what happen if DD just walk 10 times, and then he turn, and then he sit down? So he will fall down on the floor, right? Okay. Okay, you have known the meaning of algorithm already, right? So now we want to see what is the meaning of pseudocode and flowchart. Normally, we rewrite the algorithm using pseudocode or flowchart. So you have to choose. Either you want to write using the pseudocode, or you want to write using the flowchart. Okay, but sometimes the question asks you to use both of these technique. Alright, so you have to use the pseudocode and flowchart all together. Okay, so now first we want to see what is the meaning of pseudocode. Okay, pseudocode, okay, is an artificial and informal language. Alright, artificial and informal language. You have the language, okay, but if you write the pseudocode, it's not in the formal language but informal language. Okay, normally we use English language, but you can use also Malay language. It's up to you. You can write the pseudocode in Malay, you can write the pseudocode in English. Okay, pseudocode quite similar to the programming language, but pseudocode is not the programming language, but quite similar. It more or less the programming language, but it's not the programming language. It's quite similar. Okay, so what is the purpose of pseudocode? Okay, pseudocode, the purpose of pseudocode is to make humans, okay, we are the humans who do not understand computer programming. Okay, for those of some of us do not understand the computer programming, but okay, when we read the pseudocode, we can understand. So who do not understand the computer programming can easily understand the flow of the problem solving. Even though some people do not understand the computer programming, but when they read the pseudocode, they will understand. Why? Because the pseudocode is written in informal language, which is in a Malay language or English language, not in programming language. Because when you learn the programming language, normally we have the syntax, okay, we have to follow the syntax. So a lot of things that we have to learn in programming language. So some people do not understand the programming language, so we use the pseudocode. Okay, so pseudocode is quite simple, okay, easy to understand. Okay, so sometimes we write in Malay, sometimes we write in English. So that is the pseudocode. So see the example I have here. Okay, pseudocode. This is the example of pseudocode. Just now we have the problem. We want to calculate the average of three numbers, right? Okay, you have three numbers. Okay, let's say you have the number 1, number 2, and then number 3. Three numbers, 1, 2, 3. So if we calculate what is the average of these three numbers, 1 plus 2 plus 3, 6 divided by 3, you get 2. So now we want to do the pseudocode. Okay, in order to calculate the average of these three numbers. So what you have to do first, you have to start. Okay, you have to use the start here. We have the start, and then we have the end at the end here. Start, and then we have the set. We have to set sum equal to 0, meaning here the total of the number equal to 0 first, average also equal to 0. So you have to set this. Set sum equal to 0, average also is equal to 0. Then we have to input the norm 1, norm 2, norm 3. Norm 1, norm 2, norm 3 is depend to the user. Okay, let's say the first user A, he wants to input number 1 is 1, number 2 is 2, number 3 is 3. So what is the sum of these three numbers? So 1 plus 2 plus 3. So you get 1 plus 2 plus 3, you get 6. So average equal to 6 divided by 3, then you get 2. So now after that, you print norm 1. We want to print the norm 1. What is the norm 1 just now? We have 1, norm 2, 2, norm 3, 3, and then print average. We want to print the average. What is the average that we get after we calculate just now? So you get 2. So print 2 here. So if you see here, okay, can you define where is the input, where is the process, where is the output? So this is the input. We want to input three numbers. The numbers is up to the user, okay, depends to the user. Then we want to calculate the total of the numbers and the average of the numbers. After that, after we calculate the average, we want to print each number that we entered just now, we input just now, and then average. So you get the input, process, then output here. Okay, so this is the pseudocode. Okay, so you have to start with the word start and then end here. Okay, so if you see here, this pseudocode is written in English language. It's okay. Okay, the language, which language you want to write, in Malay or in English, is up to you. Okay, so this is in English language. So this is the first one, pseudocode. Okay, so if you see here, this is the informal language, right? Informal language, not the formal language, right? And then it's not the programming language. Okay, okay, this is the pseudocode. Now we move to the flowchart. Okay, what is the meaning of flowchart? Okay, flowchart is represent by using geometric shape with connected line. Use a standard symbol. Okay, normally if you write the flowchart, we use the shape. We have the shape that we have to use. Okay, and then we have the line to connect each shape. Okay, we have the line. Okay, normally we have to use the standard symbol here. Okay, the shape here, we have the shape, and then we have the meaning of the shape. Okay, we are going to see the shape after this, right? Okay, so flowchart, this is the detail of our flowchart. Okay, if you have the symbol, the shape like this, okay, we have the symbol like this. Okay, this is meaning terminal, indicates the beginning or end of algorithm, right? So if you want to start, beginning meaning start, or end, start or end, you use this symbol. Okay, this symbol. Okay, terminal here. This the second one is process. You want to process, indicate an input, computational or data manipulation. You want to process, you want to calculate the average, you want to calculate the total of the number. So we use this symbol. Okay, and then the third one, we have this symbol input output here, indicates an input or output operation. You want to input any data, you want to output the output from your program, you use this symbol. Okay, then after this we have another one. Okay, this is the decision symbol, indicates a decision point in the algorithm. Okay, if you have this diamond shape symbol, meaning here you have to choose, choose the decision, either yes or no, right? Okay, after this we are going to use all the symbol in writing the flowchart, right? And then you have the connector here, indicates an entry to or exit from another part of the flowchart. Okay, this is for connector, and then this is for loop, indicates the initial, final and increment value of a loop. And then the last one, we have the flow lines here. Okay, we use the line to connect all the symbol, used to connect the flowchart symbol and indicate the logic flow. So you have all the symbol. Okay, you have to familiar with all the symbol in order to write the flowchart. Okay, so now let's say I have I have the example here. Just now we write the pseudo code, okay, to calculate the average of the number. Now we want to use the flowchart. So you start, okay, and then you end here. Okay, now let's see the same example that we used just now. Okay, we used the example in pseudocode to calculate the the average of the numbers that we entered. Yeah, okay, so we have entered 3 numbers, we calculate the average of the numbers, but now we want to use the flowchart. Okay, so as I said just now, okay, if you want to use the flowchart, you have to get familiar with all the symbols that we have in writing flowchart. Okay, so the first one, we have to know we want to start. Okay, if you want to start, you have to use this symbol terminal here, start and then end here. Okay, if you see between start and end here, we have another symbol. Okay, depends to the operation that you want to do. Okay, let's say you want to assign, this is the assign, we want to assign the 0 to sum and then 0 to average. So if you still remember, we use the symbol, this symbol, the terminal symbol, not the terminal, the process symbol. Okay, the second one. Okay, so we use the second one, the sum equal to 0, average equal to 0. Yeah, the process. Okay, and then we input num1, num2 and num3 because this is the number that we want to input. So if you see in the symbol just now, if you want to input, you use this symbol. Okay, so I use this symbol, input num1, num2 and then num3 here. Then after you get all this number, you want to total up the number. So sum equal to num1 plus num2 plus num3. I use the process symbol. Okay, if you see here, this is the process symbol. So I put all the sum equal to num1 plus num2 plus num3 in this symbol. After that, if you when I get the sum, then I want to calculate the average. Okay, we use the same symbol, average equal to sum divided by 3. Okay, the process. After that, we want to print the numbers, all the numbers, and then print the average. So print num1, num2 and then num3, print average. So this is the output. So if you still remember, if you want to output, you want to produce output, you use this symbol in the flowchart. So I use this symbol. So if you notice here, this is the terminal, start and end here. We use the same symbol. And then this is the input, and then this is the output symbol. Then this is the process, sum, and then average. So this is the flowchart for the example just now. For the example that we use in the pseudocode, we input 3 numbers, then we calculate the average of the numbers. So it's up to you. If you feel that you can, you prefer to use the flowchart, you can use the flowchart. Or if you think you prefer to use the pseudocode, you can use the pseudocode. Alright. So this is the difference between the pseudocode and flowchart. Pseudocode, we use the informal language. You can use Malay or English language. flowchart, we use a symbol, a graphic symbol. Okay, you have to use the symbol. So it's up to you. You prefer to use which one, right? Okay. Now we can do some the exercise here. I have exercise here. Okay. Write a pseudo code. Okay, write a pseudo code and a flowchart to calculate. Okay, and display a volume of a sphere. Okay. Okay, what the question asks us to write a pseudo code. You have to write a pseudo code and a flowchart to calculate the area and display the volume of a sphere. Okay, so the formula for the volume of a sphere is given here. Uh, okay, you have the 4 over 3 times pi times radius, and then the pi, the value of pi is given here 3.41. Okay, so this is the question that we have here, okay, that we have to solve here. And then you understand already what the question need. Okay, so before you do the pseudocode, before you do the flowchart, you have to do the analysis first. You analyze the problem. So in this case, in this problem, what is the input that's suitable for this problem? So we have the, if you see here, write a pseudocode. Okay, the information that is given to us, pi times radius here. Okay, so we have the radius here. Okay, so you see input radius. You have to know what is the radius. Okay, uh, in order to solve the problem. If you don't have the radius, you don't you can't solve the problem. Okay, after you have the radius, then you can use the formula. You have process here, calculate the volume of a sphere. Okay, you use the formula that is given to us. Volume equal to 4 over 3 times pi times radius, and then the output, print the volume of a sphere. So you have known input, process, and output here. Okay, so after this, when after you have done the analysis, okay, now we move to the pseudocode. The question asks us to write a pseudocode and algorithm. So now, let's say you want to write a pseudocode first. Okay, you have to write the word start and then end. Okay, so the first one, from the question, okay, we get the clue that in order to solve this problem, you have to know what is the radius of this sphere, right? We have to know what is the radius. Okay, if you do not know what is the radius, you can't solve this problem. So you have to input the radius. Radius is very important in order to solve this problem. So input the radius. After you get the radius, calculate volume of sphere. So how to calculate? You use the formula that is given to us just now. 4 over 3 times pi times radius. If you input the radius, then you get the volume. You can calculate pi over 3. Pi is given already 3.12. Okay, and then radius, you input the radius, then you get the volume here. And then after that, the output, print volume of a sphere. So this is input, process, and then this is output. So this is the pseudocode of our problem just now. You have to use the word start and end here. Okay, then if you see here, okay, we have the solution for flowchart. Okay, if you want to use the flowchart, okay, you have to use all the graphic symbol that we have seen just now. You have the terminal, start and end. Okay, and then we are given the pi, so you have to put pi equal to 3.41 here, and then input radius, use the input symbol, and then process, use the process symbol. Volume equal to pi 4 over 3 times pi times radius, and then print the volume. So you get all the you get the volume after you input the radius here. So this is the solution flowchart for the question just now. Okay. Okay, you have seen the paces that we have in problem solving using computer. You have the first paces, define the problem, and then you have the analysis, and then you have to you have the design, right? And then in design, you know the algorithm already. The algorithm can be represented with the pseudocode or flowchart. Okay, so before we end up our lecture today, this is the control structure flowchart. Okay, In learning programming, right? In learning programming, we have three type of control structure. In learning programming, okay, you have to bear in your mind. In learning programming, we have three type of control structure. In Malay, we call it struktur kawalan, right? Struktur kawalan or control structure in English. So we have the sequence structure, selection structure, and then repetition structure. What is the meaning of sequence structure? Sequence structure meaning if you write the instruction line by line, okay, line by line, you have to follow line by line, okay, so that is sequence structure, okay. And then the selection structure here, if you have to choose, okay, you have to choose which one, you have to choose either yes or no, so that is selection structure. And then normally in programming C++, we use if or if else, okay. Don't worry about this control structure because we are going to see into detail in the next chapter, maybe next 2 chapters, right? Okay, and then we have another control structure. We have a repetition structure. In the repetition structure, we have for, while, and do while. I bring all the control structure here because I want to show to the student the flow chart for this different control structure. Okay, just now if you still remember the flowchart that we have here, this is the sequence structure, meaning here you have to follow follow line by line. You have to start pi and then input radius, volume, print, and then end, meaning here you have to follow line by line. So if you follow line by line, meaning this is the sequence structure. Okay, sequence structure, the first one we have sequence structure. But now we want to see what is the flow chart, okay, for the selection and repetition structure. So this is the flow chart for the selection structure one. Okay, let's say this is the connector that we have just now. Okay, you connect from other page, for example, connector, and then condition here. We have to choose, is this condition is true? Is it condition is true? If true, we perform this statement. If else, we exit from this flow chart, okay, this control structure. Okay, so if you use the pseudocode, if condition, okay, if condition here, is it true? If the condition is true, yes, okay, we perform the first statement here. If the condition is not true, so we exit from this structure, from this control structure. Okay, for example, okay, if student grade is greater than or equal to 60, print pass. Okay, meaning we want to check, is it true the student grade is greater than or equal to 60? Let's say I enter the grade for the student 70, so it's greater than 60, so I will print pass here. So this is the flow chart for the condition structure, meaning condition here you have to choose, we can choose true or false here. Okay, but this is for the first selection. Okay, let's say now we have the second one. Okay, the second one we have the this type of selection. Okay, is it condition is true? If this true, we perform the statement 2, not the statement 2, perform the statement 1. Okay, if it's not true, okay, we perform the statement 2, false here. Okay, then we exit from this structure. Okay, for the pseudocode, if condition, we check the condition, is it true? Yes, true, we perform the statement 1. Else, we perform the statement 2. Okay, for example, in our daily life, when we want to use the condition, let's say, is it raining today? Okay, the condition here, is it raining today? Okay, it's true, raining, so open the umbrella. The statement that we want to do, open the umbrella. If it's not raining, don't open the umbrella. That is the scenario that we have in our daily life. Okay, example of pseudocode here. Okay, we have, if student grade is greater than or equal to 60, print pass. Else, print fail. Okay, so we check, if the student grade is greater or equal to 60, we print pass. Other, we print fail. So you have two choice here, true or false. Just now we have only one choice. If true, we perform this statement. Other than this, we exit. We don't have another choice here. Okay. So this is the second structure. We have selection for second structure. You have two choice, true or false. Okay. So this is the flow chart for the condition structure. Okay. Another one, we have the flow chart for the repetition structure. Okay. Repetition meaning you want to repeat. Okay. Is it the condition is true? Okay. If the condition is true, yes, we perform the statement 1 until the condition is not true. Okay, after when the condition is not true, then you exit from the structure here. Okay, for example, okay, I give the daily life example. Let's say you want to rinse your hair, you shampoo your hair, then you want to rinse your hair. You have to check. Okay, you have to check. Is it clean or not? Is it clean? Okay, it's not clean. Okay, then you have to rinse again, until you get the hair clean. Until then you stop. Okay, uh, is it the hair clean? True or not true? It's not true. Okay, so you perform again. Okay, and then when the hair is clean, okay, then you stop. Okay, that is the example here. Repetition. Okay, so that is the example. Okay, now now we see the flowchart for the repetition structure, right? Just now you have seen the flowchart for the selection structure. Now we have to see the repetition structure. Repetition here meaning we want to repeat. We want to perform something, perform until the condition is not true. Okay, so you have the condition here. You check the condition. We perform this. Is it the condition is true? The condition is still true. You perform. Okay, you perform until the condition is not true. Then you stop here. Okay, so this is the repetition. Okay, for example, you shampoo your hair. Okay, so your hair now is not clean. The condition here, your hair now is not clean. Okay, so we want to check, is your hair now is not clean. Is it true it's not clean? Okay, your hair now is not clean, right? So is it true your hair now is not clean? True, it's not clean. So rinse again, until you get your hair is clean. So when your hair is clean, so uh, the condition just now is not clean. So now your hair is clean. So false. Okay, now the hair is clean. So you stop from rinse your hair. Okay, so that is the condition that we use in our daily life for repetition structure. So we are going to see the selection and then repetition detail after this, not after this, the following weeks. Okay, so the last one that we want to see here is the module structure. Module structure meaning, okay, you have you use for big and complex problem. You have the a big and complex problem. Okay, now if you use the model structure, you divide the problem into smaller problem here. That we call it sub-module. So you have you have the big problem, then you divide into smaller problem or sub-module. That is the module structure here. So if you see the box here, I have the module structure, main module. Okay, so you divide into sub module 1 and then sub module 2. Okay, so in pseudocode we have main module, call sub module 1. Okay, and then we perform whatever statement that we have in sub module 1. Then after that we end the submodule 1. Okay, let's say you want to call submodule 2, you call again submodule 2. Okay, so we are going to see into detail about this repetition, selection and module structure in the following week. Okay, don't worry about this structure. Okay, so I think, okay, we have learned about just a little introduction about computer programming today. Okay, we start with the computer programmer program, and then we move to the phases that we have in problem solving. You have the 6 phases. You have define the problem, analyze the problem, and then design. The the number 4, number 5, and number 6, we are going to see later about the pace, right? The paces. Okay, so after that, you have to know what you have to do in analyze design, you have to do in not analyze design, analyze pace, and then what you have to do in design pace. Okay, you have the algorithm, you have the pseudocode, and then you have the flow chart, right? So I think that's all for today. Okay, we continue the lecture next week, right? Okay, I think that's all. Okay, thank you very much.